Hello everybody, and once again welcome to Pankaj the Shillong tutorials. In this today's session we are going to deal with the IGCSE curriculum, and in this IGCSE curriculum we are going to do some basic maths. Okay, now this is very basic maths, but somehow some students of mine, they are not very clear in their concepts and they fumble with this type of questions. Okay, they can somehow manage it because they are allowed to use calculators, but then without calculators they find it a bit difficult, and they are bound to make mistakes. Okay, moreover, they don't know the concepts. Okay, so how it works and what exactly is happening, that is something you have to understand, and that is this video. Today's video is meant for. So it's a simple thing, but basic maths you are going to study in this. Okay, now whether it is useful to some of the students or many of them, that depends. Okay, but then I thought that I should go for it, right? So let us get started with this very basic concept, and this is converting some fractions to decimals, right? And this is type 1 type of questions. Okay, and in type 2 probably we'll be doing the reverse of this, that is converting decimal to fractions. Okay, and all that stuff. So I was thinking that a few questions on this each concepts, if I solve for you people, you may find it easier. If at all you are struggling with these concepts, then it will be useful to you people. Okay, so let us get started and start converting the fractions to decimals. Okay, so the very first one is 1 upon 4. Now 1 upon 4 is a fraction. As you can see, there's a numerator and a denominator. If you want to convert it into a fraction, okay, into a decimal, all you have to do is you have to go and divide. Okay, and whatever answer you get in the decimal form, that will be the answer. Okay, so 1 upon 4, if you want to divide it, you will divide this way, right? Now since 1 is less than 4, the dividend is less than the divisor, we'll start with a 0 and then a point, and then we'll put a 0 over here. Okay, and 4 twos are is 8. 10 minus 8 is 2. You'll take one more 0, and 4 fives are 20, and you get a 0 as a remainder. So your quotient is 0.25, which is in the decimal form, and that's the reason the answer here is 0.25. Fine. Okay, 5 by 12. 5 by 12, let us do the same way. 5 divided by 12. So 5 is the dividend, 12 is the divisor. Okay. Now since the dividend is less than the divisor, we'll start with a 0 and then put a decimal point and then a 0. Now by doing this, what happens? The dividend becomes bigger than the divisor. Now 12 and 50. Okay, so 12 5 is 60. Yeah. So 12 fours is 48. So let me put 12 fours 48. 50 minus 48 is a 2. Take a 0. 20 you get. Now 12 threes is 8. 12 twos are 24. So 12 ones is 12. I'll put 12 ones 12. And you get a 8 as remainder. Okay, carry on. 0. So 12 into let us take 6. 12 into 6 is how much? 72, right? And I get again a 8. So again I'll borrow a 0, and again I'll get a 6, and again I'll get a 72. Now here at this point, you see that this will go on. Okay, and you will never get a remainder as a 0. Okay, and this thing will continue. Okay, this type of numbers. Okay, 0.416666. Now this is going to be repeated. The 6 is going to be repeated. This type of decimals are known as recurring decimals, because the 6 is something which is going to be repeated endlessly. Okay, so on the top of 6 I'll put a dot. So the number is 0.416 with a dot on the top of 6. You can either put a dot or you can do 0.416. You can put a bar also. Either you put a dot or a bar. So either you put a dot or a bar on top of the digit which are going to be repeated. Okay, this is how you show a recurring decimal. Okay, So this 5 upon 12 ka answer will be 0.416 with a bar on top of 6. Okay, this can be written also 0.416 and then a dot on it. On the top of 6, there will be one dot, right? So that's the answer for the second one. Let us go for the third one. Fine. Okay. Now third one is 1 by 5. Now this is a mixed fraction. So first we'll convert it into improper fraction. So 5 ones are 5 plus 1 6, 6 upon 5. 1 by 5 can be written as 1 into 5 plus this 1 whole divided by this 5. So this works out 5 ones are 5 plus 1, 6 upon 5. Okay. So 1 by 5 is same as 6 upon 5. Now we will go and divide this 6 upon 5 and let us see what answer we are getting. Now 5, 6, right? Now the dividend is greater than the divisor. So no need of putting 0 in the decimal point. So we'll start with 1. 5 ones are 5. So you get 1 as a remainder. Put a dot over here, decimal point, and bring down 0. Now 5 into 2 is 10 and you get a 0 as a remainder. So as soon as you get 0 as the remainder, you have to stop the division process and this is your answer 1.2. So you are getting the answer here as 1.2. Okay. So 1 by 5. First you have to convert it into a improper fraction like this. Sorry, into a proper fraction, into a improper fraction like this. This was a mixed fraction. So convert it into improper fraction and then you go for division and get a decimal number. Okay. So the answer is 1.2, right? 1.2. That's done. Let us go for the fourth one. 2 1 by 3 is similar. 3 2s are 6 plus 1, 7 upon 3. So we'll do 7 divided by 3. Now 3 2s are is 6 and 1 is the remainder. Put a decimal point, bring down 0. Now you'll get 3 3s are 9. Okay, and you will see that this goes on repeating. So 3 is something on which you will put a bar. So the answer will be 2.3 bar. Okay, this is a recurring decimal, right? These are known as recurring decimal, right? Okay. Next is 2 3 by 16. Now 2 3 by 16 is a mixed fraction. So let us convert it into an improper fraction. And how we are going to do that? You will do 16 2s are 2 into 16 plus 3 whole divided by 16. This should work out to 16 2s are 32. 32 plus 3 is 35 divided by 16. Okay. So let us do this division. 35 divided by 16. So if you do 35 divided by 16, okay, you should get 35 divided by 16. Now 16 2s are 32, 16 3s are is 48. So let me go by 16 2. 32, remainder is 3. Put a decimal point, bring down 0. 16 2s are is again 32. So let me put 1. Okay. Okay. So 16 ones are 16. Then if I do the subtraction, 10 minus 6 is 4 and 2 minus 1 is 1, 14. Okay. Now 14 is less than this 16. Okay. So I'll bring down 1 0. Okay. And 16 into how much is 140? Let me try 16 into 8. 6 8s are 48. 8, 4 carried. 8 ones are 8 plus 4 is 12, 128. So 16 into 8 will be 128 and now I'll get the remainder as 2 and then 1. That's it. Okay, now 12 is less than 16, so one more 0. Now 16 into 128 is bigger, right? So 16 into 7, let me try. The 7 6 are 42, 2 4 here, 7 ones are 7 plus 4 is 11. Yeah, so 187, 112. Okay, now here the remainder will be 8. Okay, then again I'll take a 0. Now what is happening? Okay, we have reached up to 2.187. Okay, now 80. Now 16 into 5, let me try. 6 5s are 30, 0, 3 here. 5 are 5 plus 3, 8. Yeah, so I'm getting 16 into 5 is 80. And I'm getting the remainder now as 0. So it was slightly bigger, but we got the answer as 2.81875. Can you see the answer is 2.1875? Now this is known as exactly terminating decimal, because after certain point we got the remainder as 0. So whenever you get the remainder as 0, such a decimal or such a fraction is known as terminating decimal or terminating fraction. Okay. When it is not terminating, it can be either recurring, or there's another thing that I'll talk to you later on. Okay. So here in this case it was recurring, that is in these two cases, that is question number 2, it was recurring. In question number 3, it was in question number 4, it was recurring. And okay, and this question number uh, I think I've repeated this. Okay, this has been repeated, right? Fine, no issue. I'll just remove this. Okay, not an issue. Okay, chalo. So we got this answer as 2.1875. Okay. Now let us try for this 2 6 by 7. Okay. Now 2 6 by 7. First we'll convert it into improper fraction. So 2 into 7 is 14. 14 plus 6 is how much? 14 plus 6 is 20. So it will be 20 upon 7. Right. So let us try the division. 20 divided by 7. Okay. And try to see what we are getting. Okay. So 7, 20, 7 threes are is 21, 7 twos are, so we'll start with 2. Okay. 7 twos are 14. So 20 minus 14 is a 6. Okay. And now since 6 is less than 7, we put a decimal point and I'll take a 0 down. Okay. Now 7 into 7 sevens are 49, 7 eights are is 56. And 7 nines are 63. Okay, 9 will be bigger. So 7 eights are 56. Okay, so the remainder now is 4. Take a 0. Now we got 2.8. Okay, now 7 fives are 35. 5 is the remainder, take 0. And 7 sevens are 49. Okay, 1 carried. Okay, 1 is the remainder. And since 1 is smaller than 7, I'll take this 0 here. Okay. Now 7 ones are 7, 7 twos are 14, so 7 ones are 7. 3 is the remainder, take 0. 7 threes are 21, 7 fours are 28, so 4, 28. And then I get a 2 and take 0 now. Okay. So 7 twos are 14 again, so I got a 2 now. Okay. Now 7 twos are 14. Now you see that from this point, here also we got somewhere as 20. Okay, this was 20, right? Again we got a 20. So these things, are going to be repeated now. Okay, after this stage, right? So this particular number from year to year is going to be repeated again. Okay, so I'll take this as the repeating or the recurring bunch of numbers. So the recurring bunch of numbers is 857142. So either you write 2.857142 and put a dot on the first and the last digit, or the other way of writing it is 2.857142. You can put a bar on the entire bunch of these digits. Okay. So you put a bar starting from 8 up to 2, including both 8 and 2. So this is the way you have to represent the answer. Now this is a recurring decimal or a recurring fraction, right? Let us go for this 2 5 by 8. Now 2 5 by 8, since it is a improper fraction, so let us convert it into it's a mixed fraction. So let us convert it into a mixed improper fraction. So 2 8s are 16. 16 plus 5 is how much? 21. So this will be 21 upon 8. Okay, so chalo, let us do this. 21 divided by 8, right? 21 divided by 8. Fine, okay. Now 21 divided by 8, means 8 twos are 16, 8 threes are 24. So we'll go by 2. 8 twos are 16. So 5 is the remainder, and 5 is less than 8. So I'll put a decimal point, take a 0, 50. Okay. Now 8 6 are 48, 8 sevens are 56. Okay. So 8 6 I'll take 48, 2, 0. Now 8 twos are 16. 4 is the remainder, take 0. And 8 into 5 is 40. Now here I am getting the remainder as 0. So this is not a terminating fraction. This is a terminating fraction because remainder I am getting as 0. So the answer will be 2.625. This is terminating fraction. So whenever you get a remainder as a 0, okay, that means your this thing fraction is terminating. Okay. And the last one is 3, 19 by 100. Okay, so 3 into 100 will be 300. 300 plus 19 will be 319. And this 319 you have to divide by 100. Now this type of divisions are very, very easy. Okay, all you have to do is, because there are two zeros in the denominator, in 100 there are two zeros. So from this point, okay, there's a decimal over here, right? 319 means 319.0. Okay, so this decimal point you have to just shift two places on the left. So the answer will be 3.19. Okay, so here the answer is 3.19. So this is basically what you should understand about this terminating fractions, about this recurring fractions, okay, and mixed fraction, improper fraction. All these concepts were involved in doing these problems, okay. And many students, they somehow they skip these things, okay, in their lower classes, and they just take for granted and just move forward. So this is for those very needy students. Here one thing I would like to tell you, and that's a very good observation, and that I want to share with you. Okay, any fraction, any fraction, okay, if in the denominator, in the denominator has something like 2 raised to something or 5 raised to something, okay, 2 raised to x or 5 raised to x, something like that, okay, a power of 2 or a power of 5 in the denominator, okay, either 2 ka power or 5 ka power or both, then that fraction is always going to be a terminating fraction. Okay, this is going to help you a lot. This is a very important observation. Okay, any fraction in the denominator, if it has a power of 2 or a power of 5 or both power of 2 and 5, then that particular fraction will be always a terminating fraction. Okay, it will always end with a remainder as 0. Okay, it will not result in any recurring fraction or a recurring decimal, isn't it? And if the denominator is something else, okay, so I'll write here otherwise. Otherwise the fraction will be non-terminating. Now non-terminating doesn't necessarily mean that it will be recurring, because if a fraction is non-terminating, that means that remainder will never be coming 0. But then again, in non-terminating case, you have two cases, okay, and those two cases are either you will get a recurring or you will get a non-recurring. Okay, non-recurring. So both the things are possible. If a fraction is non-terminating, okay, so non-terminating can be recurring or it can be non-recurring. Okay, if it is non-recurring, those numbers are known as irrational numbers, and if it is recurring, they are rational. Okay, so keep this in mind. And this was a good observation. Now let us check over here which were the fractions in which we got terminating. Okay, now this one upon 4, okay, we got the answer as 0.25, which was terminating. Now why this happened, because this 4 in the denominator can be written as 2 raised to 2. Okay, so this denominator can be expressed as 2 raised to something. Here 12 is the denominator. Now 12 cannot be expressed in any way by 2 raised to something or a 5 raised to something. Okay, no, it cannot be expressed, and that's the reason it was a non-terminating fraction. And in the case of non-terminating fraction, as I told you, there can be two possibilities. Either the fraction will be recurring or non-recurring. In this case, it was recurring. 1 by 5. Now, since this 5 is a denominator, 1 by 5. Okay, if we convert it into improper fraction, again the denominator will remain 5 only. Okay, so denominator is 5, and this 5 is nothing but 5 raised to something, 5 raised to 1. So if the denominator in a fraction can be expressed as 2 raised to something or 5 raised to something, then that particular fraction is terminating. So this has to be terminating. And 1 by 5 we saw it was terminating. We got the answer as 1.2. It was not recurring, it was not non-terminating. 2 1 by 3, denominator is 3. Okay, so the fraction is recurring. Fine. 2 3 by 16. Now this 16 in the denominator, can you see this 16? The 16 in the denominator can be written as 2 raised to 4. Okay. So because it can be written in the form of 2 raised to something, okay, it will be a terminating fraction. And you can see here, it is a terminating fraction. Okay. It's not recurring. 2 6 by 7, non-terminating. Okay. And in the case of non-terminating, as I told you, there are two possibilities, recurring or non-recurring. In this case, it is recurring. Okay. 2 5 by 8, it is 2.675. Now 8 can be written as 2 raised to 3. Fine. And this 100 can be written as 2 into uh, 50. And this can be written as 2 into 5 into 10. Okay. Or this 10 can be written as 5 into 2. So this is 5 into 2. So 2 into 2, 2 raised to 2 into 5 raised to 2. This 100 can be written as 2 raised to 2 into 5 raised to 2. So as I told you, both 2 raised to something and 5 raised to something, if the denominator can be expressed in this way, still it will be a terminating fraction. And that is the reason 319 upon 100 you got as a terminating fraction, 3.19. So I hope that must have helped some of the students who really never knew this concept. But now that I have made an attempt to make you understand this concept, so in this, once again, I'll do a quick revision sort of thing. In this, we learned certain things. Fractions can be of proper form, proper fraction, improper fraction, and mixed fraction. Here, in some cases, we converted mixed fraction into improper fraction. Then, any fraction can be either terminating or non-terminating. I told you when it is terminating, when it is non-terminating. You can find out from the denominator. And you have to just go and do the division after bringing it in the improper fraction form. You just do the division, and whatever quotient you get, that will always be in the decimal form. Okay, so it can be a terminating decimal, it can be a recurring decimal. Okay, so that was all about converting a fraction to decimal. And in the next video, perhaps I'll be discussing about type 2 of this concept, where the decimal will be converting into fraction. Okay, and that will be interesting because there are certain recurring decimals, and you should know how to convert a recurring decimal into fraction. Okay, so till then, take care all of you. If you happen to like my video, please subscribe my channel and motivate me to make more videos like this. Okay, so till then, bye, good night.